Okay, here we go on the June 2011 Regents exam. I'm going to start off with question number 36, asking about the diameter of an inflated basketball. The trick to getting this question right is to recognize what do all these answers mean in sort of real number ideas. All right, this, number two, let's start with number one. Number one is 0.02 meters. This is 0.2 meters. This is 2 meters. And this is 20 meters. All right. A meter is about 3 feet. So you are definitely not this. You are definitely not 2 meters. 0.202 meters is 2 centimeters. That's about the width of 2 of your fingers. That's not right. So you're definitely looking at this is about a basketball right here. Next question here. This is a good one. Move that over so we can see. The speed versus time graph of an object falling. If you're clever, you'll remember that if you want to find the distance that an object travels, all right, if you want to find distance and you have a speed versus time graph, the distance is the area underneath the graph. All right, this is the easy way to do this. So we have a little triangle there, and this side is 8, and this side is 3, and so we do a little 1/2 base times height, so a little 1/2 times 8 times 3, and that gives us 12 meters. All right. Another way you could do this if you want, you could say, okay, well, distance equals VIT plus 1/2 AT squared. You could do it this way if you wanted to. You have to find the acceleration, but that's not too bad. Yeah, this is definitely your best method. So just use that. For number 38, all right, this is a calculation question. Let's look at everything that we're given and let's look at what we're trying to find. Okay, so we have 75 kilogram hockey player, that's equal to mass. We have a speed, right, 6.0 meters per second. There's some velocity. And we are trying to find force. All right, we don't know that. And we know that we have a time of 0.65 seconds equals time. All right. So what relates all 4 of these quantities? Well, this is momentum, and this is impulse. So if we're trying to stop this, we're taking something to rest. So we can set the momentum equal to our impulse. So we just have mv equals ft, and we plug in some numbers. We got 75 times 6 equals 0.65 times f, and you got to run that through the calculator. And 75 times 6 equals 450. 450 divided by 0.65. We're about right. F equals about 692 newtons. So there's our 692. All right. Number 39. 39, we have a child pulling a wagon at constant velocity. Okay, let's make a little note of this, constant velocity, because that's going to help us out later. It's saying that we need to find the magnitude of the friction force. All right. When people see friction force, first instinct tends to be friction force equals normal force times friction coefficient, and then you see this problem and freak out that you don't have a normal force and you don't have a friction coefficient. So if you don't have either of those things, then don't use this. Okay, there's another way to do this. So instead of being frustrated, use some good physics. All right, friction is a force that is going opposite the direction of motion because it's opposing it. If we're at constant velocity, that means that all of our forces need to be equal in opposite directions. Okay, so if we have friction force going to the left, that must equal the pulling force to the right. Right? And so here's another place we have to be careful. This child is pulling with a force of 22 newtons, but not all of that is going to the right. Okay, the part going to the right is only the horizontal component of the 22 newtons. All right, so we need to find horizontal component. We want the x component, and x uses the cosine, so we want to do 22 newtons times the cosine of 35 degrees, and if you run that through your calculator, you'll get the force there is about 18 newtons. So if we have 18 newtons here, we must also have 18 newtons here. All right? If you're a constant velocity, that means your forces need to be in equilibrium. Okay, they have to be equal and opposite. All right, so a net force of 0. So if 18 is this way, you have friction of 18 the other way. This last question, number 40. This also can be a tricky question if you don't think about it the right way. They're looking at, they want you to compare the magnitude of the force exerted by B on C, so it's the force between these two, and the force of A on C, so we want these two. All right. So we're going to do a little Pritz's method factor change here. All right. So B to C, we have Q, Q, okay, Q, Q, and R squared. All right. A to C, we have K 3Q times Q over 2R squared. All right, so if we pull this down and simplify it a little bit, that means we have, if we pull the numbers out, we have 3 over 4. All right, so your AC force is 3/4 of the BC force. So there is your 3/4 right there.